Okay, we're now going to go over a construction known as the crisscross construction, which is going to come in really handy for what we want to do next. So the next stop is Pappus's theorem, and we're going to use the fundamental theorem of projective geometry, which we just proved, to prove Pappus's theorem. But before we do that, we're going to need a construction which will be key to the proof. So I want to examine that first and then get to the proof of Pappus's theorem. So the construction, the crisscross construction, is as follows. Let's take lines capital L and little l, which are coplanar. So they're in a P2, not in a P3. They're coplanar, they share a plane. And let's look at another construction sending capital A, capital B, and capital C to little a, little b, and little c. We've already seen a construction a few lectures back, which in fact worked even if these lines were not coplanar. Now let's assume they're coplanar and see a more specialized construction known as the crisscross construction. So I want to consider the cross joins AB intersect AB, capital A little b, intersect capital B little a, and the cross join capital B little c, intersect little b capital C. So by cross join, I just made up that word, but it just means these two intersections, these 2 points. They're so this is one cross join and this is the other one. And let's let MB be the line connecting these 2 points. Now, I want to consider a perspectivity now. F little b from the line L to the line MB. And it's a perspectivity centered at little b from this line to this line. And what is this perspectivity going to do? Well, it's going to take A, B, and C. Remember, it's centered here at B, so it's going to pull them into this line, intermediate line MB. And it's going to pull them into these 3 points. Now I want to consider a second perspectivity centered at capital B. FB from MB to L. What is this perspectivity going to do to these same 3 points? Well, it's going to push them out. It's going to push them out to little a, little b, and little c. So the projectivity gamma b, which I'm defining to be f little b followed by f capital B, we've just done that. We've just seen that in action, and it sent A, B, and C to little a, little b, and little c. So this is our construction. This is another projectivity which takes these 3 arbitrary points to these 3 arbitrary points, but it did rely on these lines being coplanar. Now it's nice, it's a very elegant construction, it's kind of very slick. But there's something even slicker about it, which is that we actually, we centered it at B, but there's a complete symmetry here between the points A, B, and C. There's no reason that we had to center our perspectivities at capital B and little b. We could have just as well done the exact same construction, but centered them at capital C and little c, or centered them at capital A and little a. So actually we actually could have chosen any of these. And yeah, so we could have centered our perspectivities at A and little a. So for example, we would have in that case chosen all of the cross joins involving A. So one here and one here. And then we would have formed our line MA, connecting them. And then we would have looked at the perspectivity F little a followed by F capital A. So what would those do? Well, F little a would pull these points in from capital L to MA. So it would pull A, B, and C to this point, and this point. And then F capital A would push them down to little a, little b, and little c. So we would have gotten another projectivity mapping capital A, capital B, and capital C to little a, little b, and little c.